NASA's systems scan space every single day. Most of what they detect is expected, predictable, routine. But this time, something appeared where nothing should exist at all. At first, engineers assumed it was a glitch, a software hiccup, a calibration error. That happens more often than people realize. So they reset the instruments. They ran the scan again, and the same result came back. Because whatever NASA was seeing wasn't random. It was stable. It was persistent. And according to everything we know about space, it should not have been there. To understand why this matters, you need to know one thing about astronomy. Space is not chaos. It follows rules, strict ones. Objects form in specific regions. They evolve in predictable ways. And when something violates those boundaries, it isn't just unusual. It's a warning sign that something in our understanding is incomplete. This detection appeared in a region that astronomers normally consider hostile. A zone where intense radiation, gravitational stress, and energetic forces prevent long-term stability. In simple terms, anything that shows up there should fade fast, collapse, or disappear. But this didn't. Instead of weakening, it remained consistent. Instead of dispersing, it held its structure. And instead of behaving like a temporary anomaly, it acted like it belonged. That's when NASA stopped treating this as a technical issue and started treating it as a scientific problem. They brought in independent instruments, different observation methods, different teams. Optical data confirmed it. Infrared readings confirmed it. Even radio analysis showed the same pattern. This wasn't noise. This wasn't interference. This was real. And now the question became uncomfortable. If this object exists where it shouldn't, what allowed it to survive? The first explanation scientists reached for was timing. Maybe this thing appeared recently. Maybe it drifted into the region only a short while ago, before destructive forces could tear it apart. That would have been a clean answer. But the data didn't support it. This motion was smooth. This position was stable. There were no signs of recent migration, which means it hadn't just arrived. It had been there for a long time. At that point, the discussion shifted again. Maybe the object itself was unusual, denser than expected, shielded in some way, protected by a mechanism we hadn't considered. Models were adjusted, simulations were rerun, and every version led to the same conclusion. Under known physics, this object should not persist. Imagine watching a candle flame burn underwater, not flickering, not weakening, just burning calmly. Your instinct would tell you something is wrong with your assumptions. That's exactly where astronomers are now. Because when observations refuse to match theory, theory has to change. Some researchers believe this detection hints at a process we've overlooked, a form of interaction between space, energy, and structure that allows objects to resist environments we thought were lethal. Others think the region itself may not be as hostile as we assumed, that our models exaggerate the destructive forces involved. But there's a third possibility, and it's the one scientists are most cautious about. What if this isn't rare? What if objects like this have been appearing for years, and we dismissed them because they didn't fit our expectations? In astronomy, data that doesn't match predictions often gets labeled as error, filtered out, ignored. But if this detection is genuine, it suggests the universe has been quietly breaking our rules all along, and we're only now paying attention. NASA hasn't announced a breakthrough. No headlines, no dramatic press conference. That's not how discoveries like this unfold. Right now, this object exists in papers, in datasets, in conversations behind closed doors. Follow-up observations are being planned. Long-term monitoring is underway, because if it continues to remain stable, then this isn't just an anomaly. It's evidence. Evidence that the boundaries we've drawn in space aren't as absolute as we believed, that the universe is more flexible and more surprising than our equations allow. The most unsettling part isn't that NASA detected something unexpected. It's that once you notice something like this, you start wondering how many other impossible things are still out there, waiting for us to look closely enough.